right, in this next section, we're going to be talking about rates of change and the behavior of graphs. So this first slide, we're looking at the average rate of change. So what you want to do is you want to look at the horizontal distance and the vertical distance between whatever points you're looking at. So in this case, it's wanting us to go from -1 to 2. And this delta is usually signified for a change. So change in y over the change in x, just like when we were looking for the slope. This is sort of similar to a slope. So our change of y as we go from -1 to 2 is we're going down 1, 2, 3. We're going down 3, so it's going to be -3. And then our change in x is we're going +3. So our average rate of change is going to be -1. The next thing we want to look at as far as behaviors of graphs goes is when they're increasing and when they're decreasing. So I don't know if you remember learning about inflection points. So that's the point where your graph kind of changes from one direction to the other. So as you can see, we kind of have an inflection point right here and another inflection point right here. So on this interval, the graph is increasing. On this interval, the graph is decreasing. And on this interval, the graph is increasing again. So you would write those as they're written here. Or you can also spell it out this way. So let's look at the next thing. The next type of thing you would like to look for is the maxima and minima. So the extrema for the graph. So because this goes to infinity here and it goes to infinity here, we're going to be more focused on the local maximum and the local minimum. So the highest point that our graph reaches that's within the window that we have happens right here. And that's the local maximum there is 16, and that occurs when x equals -2. And then now looking at our minimum, our local minimum. So that appears to occur right here when x equals 2 and y equals -16. So our local minimum is at -16, and that occurs at x equals 2. Here's another example. So we've got a function that's increasing to here, and then it starts to decrease, and we end up with a local maximum. Here's another example. We can do a couple of things on this. So let's mark our inflection points. So it's about here, there's one about here, and there's one here. So here we are decreasing. So I'm going to put negative. Here we are increasing. I'm going to put positive. Here we're decreasing again, and here we're increasing. And then I'm going to go ahead and erase all this so we can see where the local extrema are. So we've got same thing with our inflection points. Those kind of end up being your local extrema. So we've got one here, and one here. So the local minimum is going to occur right here. And it's going to be when it looks like this is P of t equals -1. So it's when P of 1 equals -1. That's your local minimum. And then our local maximum occurs right here. So that's when P of 3 equals 1. That's going to be our local maximum. All right, and here's another example. Here we've got a graph that's decreasing and another graph that's decreasing. And then we look at the local maximum and minimums. Let's see, we've got one kind of right about there, and then one right about there. So that value is going to be f of 2 equals, let's say 1.5. That's going to be a local. Oh, this one's tricky. Let me see what they're calling this one, because you've got the two different parts here. Let me see if they're calling that the maximum still, or if they're calling that a minimum. Yeah, okay, so they're calling that a minimum. So even though it's more than this value, when we're looking at just this section, it's a minimum. So that's going to be your minimum. And then at this point, f of -2 equals about a -1.5. That's going to be your local maximum, because that's the max for this section of the graph. I'm going to skip this one. You're welcome to explore that further if you've got a graphing calculator and the path that you're planning to go down in life is going to keep you using graphing calculators. But otherwise, I'm not going to touch on it. I'm not going to be testing on it. I'm not too interested in your ability to use a graphing calculator. So the next one, here's another example where we want to show where the graph is increasing and whether or not there are any local extrema. So we've got some inflection points right here. The graph is decreasing on that interval, increasing on this interval, and decreasing again on this interval. And then looking at our extrema, we've got a maximum here at f of 1 equals 2. That's our local max. And then our local minimum is when f of -1 equals -2. That's our local min. In this one, we are looking at whether or not the graph is increasing or decreasing. So these are our toolkit functions again. Hopefully that term is getting pretty familiar to you and you're thinking about what all kinds of graphs that means. So here's our constant function, our identity function, our quadratic function. And this is just breaking it up whether or not it's increasing or decreasing, if it has a maximum or minimum, and what domains those happen on. Here's another example. So you can look at those further in the book if you'd like. This addresses a lot of the common toolkit functions that we deal with. And here's another example when you have a graph that's not continuing. It's not a continuous graph. It's a very defined graph over a specified interval, what the absolute minimum and maximums would be. So you can see the maximum point hits here and the minimum point hits there. So this ends up being what's called an absolute maximum instead of our local maximum and our local minimum, because we don't have this situation. Because it stops, then that becomes an absolute maximum or minimum. This graph will not go any greater and it will not go any less than those values that we have marked. Here's another example. So let's look at this. Our absolute maximum is going to happen when at 16, and that's for f of 2 and f of -2 equals 16. And then our absolute minimum is going to occur down here when f of 3 equals negative, what's that, 10? About -10. So this is our absolute minimum, and this is our absolute maximum. And I'm going to stop here. The rest just goes on to homework.